Today we're going to look at an example in Chapter 9, testing the difference between two variances or standard deviations. This problem is going to be very similar to the one sample version that we did in Chapter 8. We're going to be looking at a new distribution, the F distribution, which we'll talk about in just a minute. Let's go ahead and get started by reading the problem and decoding it. The average age of pets is the average age of pet dogs is 4.3 years. Two random samples of pet owners who own dogs are selected. Sample one of 12 dog owners was selected from owners who live in Miami. The standard deviation of dog ages is 1.1. Sample 2 had 10 dog owners, and it was selected from Boston. Its standard deviation was 0.7. At alpha equals 0.10, can it be concluded that there is a difference in the variances? So there's a couple things that's different about this problem than any other one that we have done this chapter. The first thing that's different is that it's asking us for a difference in variances. So we are testing a claim about variances. That means our hypotheses have to reflect that we're testing a claim about variances. So let's go ahead and write our hypotheses. So H naught. Well, here it says difference. Difference means not equal. So that means in the null hypothesis, what we're assuming is the variance of group 1 is equal to the variance of group 2. And notice that I'm putting sigma squared because sigma squared is what we use to denote population variance. In the alternative hypotheses, I have sigma 1 squared. So the variance of group 1 is not equal to the variance of group 2. This means that we have a two-tailed test. All right. So we are going to go ahead and use the p-value method. And to use the p-value method, we need a test statistic. But first, we have to know what is the distribution we're working with. Well, here, whenever we test a claim about variances or standard deviations, since we have two of them, we're going to use a distribution called the F distribution. So up to now, you probably have not seen what the F distribution is. And just to give you a quick little overview, your book goes into great detail about it. The F distribution is a skewed distribution. So it starts at 0. It's kind of high right in here, and it goes all the way. It's skewed all the way to the right. So this tail is pulled to the right. Most of its mass is closer to the 0 point here. So we have an F distribution. Its test statistic is F is equal to the sample variance of group 1 over the sample variance of group 2. Now by convention, to follow your book, and it makes our calculator happy, we're going to put the variance that's the bigger one in the numerator. So this is where we're going to put the larger variance. So even if it's not group 1, we're still going to put the larger variance in the numerator. Again, this is a skewed distribution, so it's not symmetric. We don't have those nice properties we had with the t distribution and the normal distribution. But let's go ahead and find our test statistic. So F is equal to, well, our first sample variance is 1.1, which is given to us right here. So I'm going to put 1.1, which is our sample standard deviation. So I have to square that. And I'm going to put that over the other sample standard deviation, which was 0.7. So 0.7. And I'm going to square that. And when I put that into my calculator, I get something close to 2.46938. Now, to use the p-value method, I want to be able to find the area in the tail from my test statistic all the way to the tail. Since we have a skewed distribution here, we are going to do the same thing we did in Chapter 8. And we're going to go from this test statistic to positive infinity. No matter what our hypotheses are, we're going to always go from positive infinity. We're always going to go to positive infinity. So we're going to use the F CDF because we're working with the F distribution and we want to accumulate the area. And the F CDF you can find under distributions, and you just have to keep arrowing down. it takes the lower limit, which you're going to put as 2.46938, the upper limit, which is infinity. So let's see, lower limit, upper limit, and then we're going to have degrees of freedom for the numerator. Well, degrees of freedom is just going to be 1 minus the sample size. So let's see, the sample size is 12, so that means we're going to have 11. And then we also have a degrees of freedom for the denominator, which would be, so 10 is the sample size, so 9 is the degrees of freedom. When we put that into our calculator, we get 0.092663. Now recall that we had a two-tailed test. This area is just area for one side, from the test statistic to the tail of one side. So we need to multiply this by 2 to get the probability for the other side. So that means we get a p-value of 0.1853. This is our p-value. Now that p-value is greater than our alpha value. If you recall, our alpha value was 0.1, and this p-value is greater than 0.1, so our decision is going to be do not reject H0, which means that at alpha equals 0.1 level, there is not enough evidence to support the claim that the variances, between, so what we were comparing was the variance in age between dog owners in the two cities. So there's not enough evidence to support the claim that the variance in dog age between the two cities is different. Okay. Now in your calculator you do have a, if you go to, so on a side note, I'm going to change colors. If you went to stat, and then you went to test, there should be an arrow. You do have a 2-sample f-test. So you could play around the 2-sample f-test. It should give you all the same information that you found by calculating it by hand. But just know for your midterm and your final, you may be asked for just the test statistic. You may be asked how to compute the f-statistic. You might be asked for just the p-value. So these are things that you need to be able to find by hand. All right, feel free to email me if you have questions.